day. Um, so, Stacy, would you please introduce yourself and your team of fabulous women? We're so excited to have an all-women panel tonight.
Oh, yes, for sure. Yeah, thank you to all of you water advocates for having us here tonight to talk to you about some of the work we're doing at the Bureau of Geology for water issues here in New Mexico. It's nice to see a lot of familiar faces and names. So I am Stacy Timmons. I'm the Associate Director for Hydrogeology at the Bureau of Geology, and I've been working here at the Bureau of Geology based out of Socorro for almost more than 20 years now. And along with me, I have Rachel Hobbs, who is Water Data Program Manager, and Layla Sturgis, who is the Aquifer Mapping Program Manager, and you're going to hear from each of them sequentially here in a couple of slides. So I'll go ahead and get my slides going, and I would encourage you to, if you use a phone and know how to use a QR code to navigate, to have that ready. And we can also share the slides with you afterwards so that you can find your way to some of the information that's provided here. Okay. There we go. You can see that? Yes. Was that a yes, Brady? Yeah, okay. Great. So there are 3 programs now at the Bureau of Geology that relate to water. That's the Aquifer Mapping Program, the Water Data Act, Water Data Initiative, and the Water Education Program. We're just going to be focusing mostly on Aquifer Mapping and water data for tonight. And so we are a state geologic survey at, there's a lot of Zoom things happening on my screen over here at the same time. Okay, okay. Go away. This is nice to have friends along the panel to help me through my presentation. So the Bureau of Geology is at New Mexico Tech, and we are non-regulatory state survey. Many state geologic surveys are housed at universities. About half of them are under executive divisions of other states. And so we have been doing geology and earth science for the state of New Mexico since 1927. There are several programs here at the Bureau of Geology. We're just highlighting tonight the water programs, but we also have geologic mapping and geologic hazards. The hydrogeology program is listed here. We also have energy, which includes the oil and gas division, as well as the new geothermal program. In our mineral resources, we have a mineral museum as well as mining and economic geology research. We have laboratories that includes water chemistry and a variety of age dating for rocks and XRDs, so you can look exactly what the mineral content is. There's a variety of labs here. And then we have a substantial outreach and education effort. The image on the screen on the lower right is the entrance to our building. If you are rolling through Socorro and need a quick stop or a long stop, I encourage you to stop by the Mineral Museum and the bookstore. It's a really nice facility to wander through. A lot of cool rocks and minerals to see. So as I said, there are 3 programs here at the Bureau of Geology. The Aquifer Mapping and Monitoring Program really focuses on trying to understand what our groundwater resources look like here in New Mexico. We do that in a variety of ways, with short-term, small-scale studies to much bigger regional studies to much bigger statewide efforts. This has been going on since the late 1990s. A lot of the work that we do also includes groundwater level monitoring, which you'll hear a little bit about right now. That's funded largely by Healy Foundation. The Water Data Initiative, which Rachel will be talking about, started in 2019 after passage of the Water Data Act. And that is an effort to really make water data more accessible for all of us here in New Mexico. And then the Water Education Program is the newest program added that is really working to educate people in decision-making roles about water issues here in New Mexico. And we do that by bringing decision makers out to field locations and having various presentations at the field site, as well as in a classroom setting, so that everybody can kind of see things from the same perspective and be out of the legislative confines and ask all the questions that they have about water issues. So currently our team is about 12 people, 10 part-time people, and we have, I think it's 5 vacancies right now that we're working to fill. So we have positions open right now that are posted on the New Mexico Tech HR page if you guys know any hydrogeologists or data folks. So just to kind of get into it, for those of you who are not aware, groundwater is one of those tricky things that we deal with here in New Mexico, where because it's underground and out of sight and amidst a pretty complicated geologic framework here in New Mexico, it makes understanding our groundwater resources even more challenging. The geologic map that you can see on the screen here, which maybe you can pick out a couple of colors and lines. The different colors represent different geologic units that have different hydrologic properties and different geochemical properties. The water moves through those different colored units in different ways. And then crisscrossing a bunch of that are black lines, that's faults that will have impacts on how groundwater moves across those linear features that are existing in the subsurface. And then maybe if you look really closely, you can see some little red dots. Those are volcanic centers. So amidst all of the other complexity of different geologic units and faulting, there's also volcanic intrusions where our landscape has been interrupted and groundwater flow also gets interrupted in the subsurface. So really trying to like understand what our groundwater, our aquifers look like in this three-dimensional space in a state like New Mexico, where we have this tremendous landscape and complicated geology, is never a straightforward process. I usually compare it to the state where I was originally born, which is Nebraska. And as you might know, Nebraska is pretty flat, and so are the rocks, and so are the aquifers, much easier to map out than they are here in New Mexico. So many of you are probably wondering, how much groundwater do we have so we can plan our future and we can make decisions, and maybe about what the water quality is. Do we have a lot of fresh water? Do we have a lot of brackish water? Are there contaminants in there that we need to be concerned about? And then how is that water being recharged? Is it receiving water actively, or is it disconnected from recharge processes altogether? And is it connected with rivers nearby? So these are the kinds of questions that we're working to answer with the Aquifer Mapping program, and we've done a lot of work in various places around the state, but we don't have all the answers yet. I'm sorry to say tonight. Just to kind of set things up for you, to give you a little bit of a mental picture about what groundwater is. It's not a big bucket of water under the ground. It's not a big lake underground. Instead, it's the rocks, which I'll give you a few pictures to set that up, which have water within the little tiny spaces between the rocks, or cracks within the rocks that water can move through. So we consider an aquifer just rocks with water in them that can transmit water, move the water through. It's because it's not directly visible at the surface typically, it makes characterizing it much harder. We usually only see groundwater where we have wells or where we happen to have a spring coming out of the ground. Groundwater is moving in the subsurface, generally flowing downhill, down a gradient, whichever way gravity is pulling it, which means that it's pretty slow moving in some places. And often it can be moving so much slower that it's much slower than where we pump it out. So in places like, I saw LaDonna Clayton on here, in places like eastern New Mexico, groundwater is moving much slower than it is being pumped out in that region. And so oftentimes we don't see how groundwater is changing unless we are tracking it by measuring groundwater levels in wells, or seeing changes in how a well might be producing water. And so sometimes it takes a lot of time for those changes to actually be observed. And so that's another kind of challenge to knowing what's going on in the subsurface. And just one thing I think it's important to be aware of is that as we go deeper, so units at the top of our subsurface are kind of sitting there held down by gravity. And as we go deeper and deeper, those rock units the weight of the overlying rocks are pushing on the deeper rocks. And so as you go deeper, typically our formations tend to be tighter, and also water in those deeper formations is moving much slower. So it has time to pick up more mineral content and become perhaps more salty. So as we go deeper, it isn't always a better solution. It's the same as it is up at the surface. So those are just kind of some basics to think about. I think I took this picture driving down I-25. So this is the picture of what we would consider some of our best aquifers here in New Mexico. This is the Santa Fe group. This is the sand, clay, and gravel units that are throughout the Rio Grande Rift, the central part of New Mexico along the Rio Grande, and in other places. This material makes a really nice aquifer because it has different sized rock materials, and there can be a lot of water between those materials that can move fairly easily, and it can store a lot of water. As opposed to fractured rock aquifers. So here are some examples of volcanic rocks that have cracks in them. And so if you can imagine, if these rocks were in the subsurface, they might have a little water in some of the cracks that are vertical there. And depending on how the cracks are oriented, if a well is drilled into them, they may or may not be able to be connected to those fractures. And so these are not the best aquifers, but we do have a few of these in New Mexico, especially in some of the mountain ranges where we have granites and volcanic materials. And then I did a quick search as we were preparing this presentation just to see what is the internet think an aquifer is. And the first picture that came up was this image, which is a cave with that kind of lake image. And this is why a lot of people think of, you know, a big, vast lake of water underneath the ground, is because these are the kinds of images. This is very uncommon. As a real aquifer, it is basically where we have caves and dissolved rocks that have interconnected, and sometimes you do see something like this. There's a few places out by Roswell and Carlsbad where this is potentially what the aquifer looks like in the subsurface. But this is not a super common aquifer here in New Mexico. So I just wanted to also highlight for you all a little bit about how recharge happens here in New Mexico. This map that you can see has a lot of beige, and that beige represents places where less than 2% of the annual precipitation that falls in that space is going to be recharged to the groundwater. Very little of our precip actually makes it all the way through the sediment material, the soil, the root zone, and recharges our aquifers in places that are in that beige zone, along rivers. And then in places where you see the different colors, that's where we have much higher recharge rates. And so you can see the color scheme going more towards blue gets upwards of about 40 to 50% of the annual precip is able to recharge and get into the ground, into the aquifer in those regions. So that is an important mental picture to have, where you can see recharge happening as along our streams and rivers, and then many of our high mountain regions. And these are also places that are very susceptible to fire right now, and places where we really need to work on forest health and restoration so that we can continue to see recharge to our aquifers. I wanted to also throw at you a little bit of technical data for this presentation. The map here that just came up shows what we use carbon-14 to date groundwater. So similar to archaeologists using carbon-14 to date, you know, a piece of wood from an archaeology site, we can also use that to date the groundwater. And so the map here shows a variety of points that are different sizes. The size of the point relates to how deep the well is. So the bigger the symbol you see on there is a deeper groundwater, deeper well. And then the color, the yellow colors are the older waters. And as it goes towards blue, from yellow to green to blue, those are the bluer colors are the younger waters. And so you can start to see that in some places where you see those big yellow circles, like up in the San Juan Basin in Northwest New Mexico, there's some big yellow dots. Those are places where the water is deep and fairly old. It has very low % modern carbon. So virtually none of that water has been recharged within the life cycle of carbon-14. There's a lot of greens and blues along our mountains and along some of our rivers. You can see the Sacramento Mountains has a good amount of recharge happening in that area. So I just wanted to kind of give you a little bit of perspective about New Mexico's recharge processes, and that it isn't always happening everywhere. And one important thing also to note on this map is that there's a whole lot of places where we don't have any data, where we really don't have quantified numbers to say this is exactly what the recharge process is looking like in these areas. So there's a lot of work to do. So I'm going to hand it over now to Layla to talk about some of the regional projects and statewide projects that we have going on under the Aquifer Mapping program.
Thank you, Stacy. I hope you guys can hear me. Yeah, so
I have to lean in just a little bit more. Yeah, you're not hardly in the screen. There you go.
Screen. Okay. We're not used to being on one screen.
Yeah.
Yeah, so I'm just going to give you an update on some of the regional work that we've been doing. And here's just a list of some of the projects I'm going to talk about. People really love to hear about the 3D aquifer mapping. It makes really awesome geologic maps. The image we're looking at is all of our regional projects that we've been working on over the years. And the gray areas are ones that have completed and they're published, and the green ones is our active work right now. So we have quite a bit of active work, and we've really done quite a lot to cover the state, but as you can see, there's still some regions we really need to study. So let's just get into some of these regional projects. So the 3D aquifer mapping, you can see our progress over there on that map. We've soon we'll have almost the whole southeast quarter of the state mapped, which is awesome. These programs really started in 2019, and it was funding from the Healy Foundation that got this going with the Estancia Basin. And more recently, our most recent funding has been coming from USGS State Map. They have a nationwide initiative to build 3D geologic maps. And so this is fitting really nicely with that goal. So I'm really excited to be able to partner with them to make these projects come through. And we did partner with MNRD and the Oil Conservation District Division on the Delaware Basin, because it's such a high interest for them to be able to permit their applications, and they want to be able to protect groundwater, and they need the best data they can. And so they wanted a digital product where they could look at if a spill or if a well was being drilled, what was the appropriate zone to screen, and to just make that process quicker and safer for everybody. So that's really great. And so we've completed the Delaware Basin. You can find that online, and the Pecos Slope. Salt Basin exists right now as a Monflow model from student thesis work, and we're going to be converting that soon to a GIS model. And the Central High Plains is really close. It's looking great. And I just also want to point out that we're not the only ones doing 3D work. So as I mentioned, USGS has that same initiative, and so they have some great models in New Mexico as well. Our goal, as we've been working on these, has been to make sure that these models are useful to as many people as possible. So we want to make sure they're easy to import, both in GIS and maybe other decision support models. It would be great if we can use these to estimate aquifer volumes and to define brackish and fresh aquifers. Those are our goals. It's not always easy to meet all of those goals, and I'll get into a little bit of why. But our products that we are serving from these projects are geologic maps and hydrologic maps. So they have digital surfaces that you can download with layer thicknesses and elevations for both the tops and the bottoms of the geologic unit. And we've also estimated tops and bottoms of the aquifers. We also, I'm really proud of the data uncertainty maps that we make with these, so that people can have a little bit more understanding if they're trying to make a site-specific decision. And these are really big regional models we're making. And so it's nice to be able to say, you know, this area, we might have 200 feet of uncertainty in this region, and other areas where we have a lot more data, we could say that we're really confident in this region, and we feel pretty good about the model there. So I really think that's a good product to serve with that. As I said, this data is GIS map packages primarily, but we have been converting all of these into Google Earth files. So you can go look and download a depth to water for these and look at it on Google Earth, plug in your address and say, okay, what is the elevation of the aquifer here? And we've actually been doing it not just for our 3D products, but we've been going back and digging out the digital files for some of our older regional work and converting those to Google Earth files too. So if you had a project or a region that you were really interested in, it's worth going back because just in the last month, we've been publishing a lot of this data. So there is some new stuff on some of these older regional projects. And you can find it spatially on maps.nmt.edu. That's that, you'll get that same kind of project polygon map that you were seeing on my first slide with the greens and the grays. You can find any of those projects there. And of course, you can find our work on the New Mexico Water Data Catalog. So here's just a little snapshot of what our models look like right now. The one at the top is one in progress. I like to show that one because you can kind of see the difference in data density we're working with. So for the eastern edge of the state, there's a lot more data, and as you're at the bottom of the model, you're getting a little bit more of the oil and gas data. But as you work up into the northwest corner, I have very little data, so I'm not going to have a lot of information I can say about with a lot of certainty for some of the structures in that region. Yeah, so that, and also for that map, the water levels that we're using are really just from the time the well was drilled. So our water table is really going to be data that's maybe from, 70-year range in data that we're going to use to compile a water table surface. So that's also very frustrating. To move on to just some of the regional projects where we do get to fill in some of this data. This is a great one that is about to be published. We're going through the last painful steps. Stacey, I have some edits you should look at on this one. So this is Rio Arriba County. This was funded by state appropriation. And we are lucky to have recurring or some additional funds to continue this work, but it was really focused on several communities within Rio Arriba County and trying to estimate how much groundwater they had. So we measured 100 water levels and took 70 water chemistry samples, including biological data, which we don't usually do. So we were looking for E. coli and total coliform. This one, it was really cool because we were able to create new geologic cross sections during the process of this map. So it's really nice. And we have a new graphic designer. And so we took the opportunity to make some new block diagrams of the region. So there's 3 of these diagrams to help the communities really understand how their water is moving through their systems. And another really cool thing that we did is we looked at trying to estimate what is the saturated thickness. Most of these communities are relying on very shallow alluvial aquifers, that blue region in the map. And so we used the well logs from the drilling records and tried to estimate how thick is that, the bottom of the well, and see if they completed all the way to the bottom of the alluvium, and then compared that to the surface elevation and calculated a saturated thickness. And we're going back with the additional funding we have now on refining that work in more regions in the county. And it's looking really good. Notwithstanding a few silly well records that we've gone through, but we're doing what we can with the OSU drilling records. Is coming out really good, I think. This is another project that is gearing up, Santa Acacia monitoring. So we're looking, this is in the Socorro area. So we're looking from Santa Acacia all the way down to Fort Craig. So just beyond Bosque del Apache. And we're going to install, the wells are already there. We have monitoring wells at each of these lines you see. So we're calling those transects. So there's multiple wells at each of those lines you see across the river. So they're on both sides of the river and also on either side of the low flow conveyance channel. And we'll be installing real-time water level monitoring device so that we can watch from a dashboard online what's happening with the water levels out there. And 2 graduate students will be getting their thesis to help us with this work. So they're going to be looking at groundwater interactions and soil plant response to any possible changes. There might not be changes, they might just be observing, but if there is possible reoperations, they're going to be excited to catch that with their stream gauges and wells. I don't know if you guys are aware, but we do, we've been doing for a few years now the Albuquerque area groundwater table map for the Albuquerque-Bernalillo County Water Utility Authority. And this is ongoing, but we have, I believe this is 22 data up here. And we do this every year. We're trying to look in winter, and if you try to look at the same time every year, we can try to calculate changes in storage in the water table out there. And of course, one of the really projects that's near and dear to my heart I really love is the Healy Groundwater Monitoring Network. Stacy mentioned that a little bit in the beginning. This is a really cool project where homeowners can have their wells monitored for free, not just homeowners, municipals, anybody who has a well and they're concerned about their water levels in their well can join. We're really trying to fill gaps where there's no monitoring. We're really trying to catch communities that are only supported by one well. People that are extremely reliant on groundwater but might not have the means to collect the data and understand what's happening with their resource. So we work collaboratively with the USGS and the Office of the State Engineer to make sure we're not overlapping any efforts and spreading our dollars as far as we can. If you guys are, I'm always happy to visit wells that fill gaps in our network. So please, you're always welcome to share information about the Healy network with those you think might be a good fit. And eventually we would like to drill purposeful wells for this project. Right now, these are all almost entirely active pumping wells, and they might not be completed all the way through the aquifer, but we get what we can to help us understand New Mexico's resources. A project that's in development right now, we're going to have a first draft done in the spring, and then going to another year probably for publication, then developing the final content, but is developing groundwater summaries for the state. So we've kind of divided up into some pretty broad regions right now. We have sub-regions within that, but this was in hopes to maybe be in line with water planning. They might not use similar boundaries, they may not. These are based primarily on surface water boundaries, but that we use some of our geologic intuition to make them a little bit better match the groundwater divides that we know about. I think these are going to be really useful for regions to understand what data they do have and what data they don't have. That's really a hope of mine, that these will be useful in the planning process to say, hey, we really need more monitoring in this region. We really don't have much. Or that cool slide Stacy was showing about measuring how much recharge we're going, there's almost none in my region. We really need to do some of that. So I really hope that they can provide a lot of current data, but also point out where we need to get new data. And another project, this is just looking at our aquifers, but trying to define them just in 2D. What are our aquifers? What do we think are our major and minor aquifers right now? What we're looking at on the screen is what USGS considers our major aquifers. You can see most of New Mexico isn't considered to have a major aquifer, and we know that people are living off groundwater in those regions. So we would like to refine this to better reflect the knowledge we already have in New Mexico about some of these regions. But it's still a really good first step to try to make this map ourselves and just define the 2D extent. And I think that will tie in well with the fact sheets I was just describing earlier. So I think these projects will go hand in hand really well. And with that, I'm going to turn over to Rachel, and I'm going to scoot over.
Okay. I think there are some folks on the call tonight who are very familiar with the Water Data Initiative, and maybe you even attended this workshop that there are pictures on this slide of. So for you, some of this will be a little bit of a review. I'm going to talk about what the Water Data Initiative is, but then also how we are working to support this aquifer characterization work that Stacy and Layla were just talking about. Because in order to do this work, they need data, and not just data that we're producing at the Bureau of Geology. They need data from all sorts of different organizations that are working in New Mexico: USGS, Bureau of Reclamation, New Mexico Environment Department. There's numerous other agencies producing data. So Stacy mentioned the New Mexico Water Data Act was signed into law in 2019 in recognition of the real challenges that we face here with climate change and water scarcity issues. And our mission is to make finding water data simple. We want New Mexicans to have accessible and useful data for water management and planning. So we kind of have to put on multiple hats. You know, sometimes I think about my role as a Bureau employee and how the Water Data Initiative is supporting the work that's happening here in the Aquifer Mapping program at the Bureau, but we are also working to make data just accessible for anyone who needs it in New Mexico. So who is part of the New Mexico Water Data Initiative? The New Mexico Bureau of Geology and Mineral Resources is the convening agency. Our role is to lead reporting. We host workshops. We have outreach events. We coordinate the other directing agencies, and we're working on a big data integration project, which I'll talk a little bit more about in a minute. We also are part of the directing agencies. These agencies are named in the Water Data Act and include, in addition to the Bureau of Geology, the Energy, Minerals, and Natural Resources Department, the New Mexico Environment Department, and the State Engineer and Interstate Stream Commission. And all of us together are required by the Water Data Act to collaborate with other regional and national efforts to share, integrate, and manage water data. And then finally, we have a ton of other participating agencies. If you go to our data catalog, you will see that right now there's 60 different agencies sharing almost 300 different data sets. And ultimately, our goal would be to have any agency that's producing water data in New Mexico to be coordinating with the Water Data Initiative and working to make their data more accessible. And I think many of them are, which is great. So I mentioned our data catalog. The easiest way to find and share water data through the New Mexico Water Data Initiative is by going to our water data catalog. It's built on an open source platform called CCAN. It's has over, as I mentioned, it has 60 agencies sharing data and almost 300 data sets. And I would encourage you to check it out. It's easy to search, and there's a lot of different data sets there. We have hosted data sets, Excel spreadsheets that you can download and view. And we also have links directly to applications and tools that are made available by other agencies. And if you go to our website, newmexicowaterdata.org, you can click on data and it navigates you to the data catalog, or you can go to catalog.newmexicowaterdata.org. But the data catalog is really just one tool in our data sharing toolbox. The kind of larger mission of the Water Data Initiative is to develop a data sharing infrastructure for the state of New Mexico, specifically water data sharing infrastructure. And the way that we're doing that is through the use of application programming interfaces, or APIs. So this is my little moment, education moment on APIs. APIs are ubiquitous. We all interact with them every day. All they do is allow computers or applications to exchange data or information. A really common analogy is this idea of the server at a restaurant. You go into a restaurant as a customer, you sit down, you look at the menu, and you order your food. The server takes your order from you back to the kitchen where the chef makes your food. Then the server brings your food back out to your table. The server in that analogy is like an API. It's bringing your food, it's exchanging information from one point to another. And as I mentioned, APIs are pretty ubiquitous. Any online system we interact with on a daily basis use APIs. So like any online store where you're buying something, like Amazon uses APIs to exchange information between the sellers and the payment system. Medical information system. So like if you can access your medical information online from multiple different visits or different providers, that's through the use of APIs. Weather apps. All weather data in the United States essentially is produced by the National Weather Service, and that the National Weather Service makes that data available for use in weather apps that we use. And then finally, another example is thermostats, smart thermostats, or any sort of smart equipment in your home, like a smart refrigerator or garage door opener. It uses APIs to communicate between your phone and the piece of equipment. And APIs are for computers. So unless you're a programmer, you really won't interact with them directly. They're kind of operating behind the scenes. So why do you need to know about them? The reason why I bring them up is because, all those things that I just mentioned have an infrastructure of APIs that are used to transmit data, nationally. And that's been done through because there's an economic incentive, or maybe there's an overarching, federal government organization like the National Weather Service that makes that happen. But the Water Data Initiative is trying to do that for New Mexico. So when you hear me say API in this talk, really you can just take that to mean water data on the internet. We want water data to be accessible on the internet, and we want to create the infrastructure for that to happen. So, and here's another visualization of how that infrastructure is going to be created. And we've already kind of made some significant steps towards this. And I would also say, if you're a geomorphologist, please don't evaluate this image too critically. It's more a way to communicate the kind of overarching data sharing infrastructure through this idea of stream confluence and this cute beaver dam with beavers. So we have our data providers who provide water data here in New Mexico. They're at the headwaters of these streams. That can be really any organization like us here at the Bureau of Geology, or like the USGS, a federal organization, academic organization. Those data providers are all collecting data, and that data exists in multiple different formats. So sometimes we have data just in spreadsheets or CSV files, or maybe an Access database, or maybe we are using GIS and it has like an Esri geodatabase, but it's in all sorts of different formats. So how do we take all of those different formats and work to get those available on the internet through the use of APIs? One way to do that is to post data to the data catalog. The data catalog actually has a data API, so Excel files or CSV files, things that are machine readable, can be made available through that API. Another way is a lot of geodatabases, like Esri geodatabases, have a REST server that can be turned on, and the data are available on the internet that way. So they have their own API. Another option for agencies that have the capacity is to build your own API. And that's actually what we're doing here at the Bureau of Geology. So we've been working to develop an API that is now public. And if someone had the programming skills, they could go to that API right now and have access to any of the water level and water quality data that the Aquifer Mapping program has produced. And also, I'm talking about the Bureau of Geology right now, but lots of other agencies are working on this as well. So the Energy, Minerals, and Natural Resources Department actually are in the process of building their own APIs. They just published them, and they're adding new ones all the time. So we have a lot of different agencies that are working towards this right now. But then once the data is available on the internet, what happens then? What we really need to do is to be able to take all those different data sources and integrate it into unified formats, so that it can be used for different use cases. So for example, the example of the Aquifer Mapping program, when Layla's team is doing a hydrologic study, they need data from multiple different sources, from the Bureau of Geology here that we produce, also from the USGS, from the EPA's water quality portal. And it takes a huge amount of human resources and just time and energy to go to all those different locations, download all of that data, compile it into a unified format. So if we can make that process faster, then we're going to be making aquifer characterization go a lot faster for the Aquifer Mapping program. And this will also, our goal is also to do this for multiple use cases. So hopefully be helping other agencies with the work that they need as well. And yeah, once you have that integrated data, you really can use it to do anything, create applications, tools, maps, or dashboards as you kind of need. This is just, I mentioned our API. This is public now. If you are someone who is a programmer or you know programmers, they could use this tool to access all of the Bureau of Geology's water data. But we know that most people are not programmers. I am definitely not. And so we're also working on tools that anyone can use that have map interfaces and are intuitive to access data from the Aquifer Mapping program and also integrated data. And I'm not doing a live demo today because these are not quite ready for prime time, but I'm hoping that maybe I could come back in 8 months or a year and show you these and be able to give you a live demo and have them work in real time. So the first thing that we're working on is the groundwater dashboard. This will be a place to view groundwater data from different sources around the state. Users will be able to quickly view where groundwater data are available, where they're maybe not available. The goal is to have folks to be able to click on a point and access a hydrograph, see the data that's available for that location, see what the data source is. And there's a lot of data sources in New Mexico. The example I'm showing here has data from the Bureau of Geology, USGS, and Bernalillo County. This is just an area focused around Albuquerque, but there's a lot more agencies that are producing water data that we want to incorporate here and that we're working to get into this dashboard. So we know we have a lot of sources to add, and there are going to be many more becoming available in the next year. And then the next thing we are working on is this data integration engine, which is kind of similar to the groundwater dashboard, except that it will be a place to download all of that data in a unified format. So the goal is that a person could come here, you could select the parameter you want, like depth to groundwater, draw a polygon like I have around Albuquerque there. You would be able to see all the data sources and then download all of that data as a CSV in a unified format. So you'd have it all in a single format for every source. And, you know, this will make some of this work that we're doing to characterize the hydrology of New Mexico a lot easier. We're also working on multiple tools. So we've developed a command line tool for more technical users. And we're also working on this user interface that anyone will be able to use. So those are some of our big projects, but I will also say that we really want to hear from you at the Water Data Initiative. So I'd encourage you to visit our website at newmexicowaterdata.org. If you have questions, you're also welcome to email us or email me. Like I mentioned, you should visit the data catalog and look around. I would also say, have a little request, which is that if you go to the data catalog, you'll see that there is a survey there. We're really trying to do some user research and understand where we can improve the data catalog, where we can make it more usable. So if you have some time tomorrow, it says, if you go there, it says it's going to close on the 18th, but I think we're probably going to leave it open a little longer. So if you have time within the next few days to take a look at the data catalog, fill out the survey, let us know what works for you, what maybe you find confusing, how you want to use the data catalog, what features you'd like to see. That would be really helpful. Yeah, and that's it for me. So back to Stacy.
Okay. We are coming to the home stretch, you guys. Our amazing listeners for staying up at this very late hour. My dad goes to bed at 7, so I'm impressed y'all are still mostly upright. Okay, so I just wanted to highlight kind of where we're heading right now with aquifer characterization. There was, as many of you probably know, a call to action for New Mexico through the governor's 50-year water action plan. And within that, under the new supplies category, section B, there was a particular topic around improving groundwater mapping and monitoring. And then as you read the text in there, it basically says that upon complete funding, our agency, the Bureau of Geology, is tasked with characterizing all the major and minor aquifers of the state, the fresh and the brackish water, characterizing all the major aquifers in particular by 2032. So hurry up and get it done, Stacy. and build a statewide groundwater monitoring network with at least 100 new dedicated wells. So that thing that Layla was just talking about, where we're using existing wells to track groundwater level trends, they're not dedicated. They're not actually drilled for the purpose of science and tracking groundwater levels. So the goal here under this 50-year water action plan is to make dedicated wells and have those all set up by 2037 with streaming data. One thing I want to just, before I forget to say it, drilling these wells is an opportunity for us to really see what's going on in the subsurface. So the idea here is that we're not just drilling wells to make monitoring wells. We're going to drill them and collect all the science that we can possibly collect going downhole. So that includes a lot of the things like they do in the oil and gas sector, where they drill and collect geophysical logs going down, collect water samples going down, characterize multiple aquifers at depth. Some of these might be really deep, and then completed to different levels for monitoring different depths of aquifers. Okay, so a lot of the slides that are coming after this are what we're aiming to do to fulfill that goal of aquifer characterization. So what complete aquifer characterization really should include is maps of the geologic units and the hydrogeologic characteristics of those units. A lot of that is covered in the 3D aquifer mapping, but that is based on only existing data. The other thing that we have to include in a complete aquifer characterization is depth to groundwater and groundwater elevations. That helps us know which way groundwater is moving. It also includes what are the boundaries, both on the surface and in the subsurface. What are the geologic structures that are impacting flow, and where are the recharge areas? And then finally, what exactly is the water quality of those aquifers? And so that map that Layla showed earlier with the green areas that we're actively working and gray areas that we've previously worked, all of those are driven by some particular region question or issue, not necessarily for the goal of doing this complete aquifer characterization. So some of these areas maybe have a county-wide study that's focused on water quality. Some of these areas are really focused on groundwater levels. So the idea here is that we bring together all of that previous information and launch from there to complete all 4 of those categories of data. And with that kind of information, what we can do is, as I mentioned, we can really start to understand which way groundwater is moving. We can estimate how much groundwater we have in storage. We'll really begin to understand where is recharge happening and how is our groundwater interacting with surface water. We'll be able to really know more about water quality and how it's impacted in future conditions, perhaps with less surface water, as we've heard in the face of climate change, perhaps knowing exactly how that recharge is happening and how having less recharge to our groundwater is a consideration for water quality. And then I know a big goal for the state is to eventually have a complete water budget. So we know what all of our different accounts for water actually look like. And so a couple of maps here. The map on the right is the Santa Fe area and the Española Basin, where a lot of work has been done, and we can bring that to bear. We have maps of what the subsurface shape looks like, where the faults are, which way groundwater is moving. This is a really good example of what we can do with more complete data and filling in data gaps where it doesn't already exist. One of the topics that has been coming up a lot lately is related to brackish water and where we do or don't have brackish water here in New Mexico. So I wanted to highlight that topic here real quickly. It's important to note that at the state engineer's office, in terms of water rights, the available potential brackish water to be used is right now in the depth of over 2,500 feet, so quite deep, and in the salinity range or brackish range of what we call total dissolved solids, so how much salt is in the water, has to be more than 1,000 milligrams per liter or parts per million. They're the same, but that 1,000 is a key category. So it's kind of salty, and it has to be greater than 2,500 feet deep. And so what we have done in the past is take all the data we can get our hands on and try to understand, okay, what does this look like? What does our deep, non-potable water resources look like? And so we compiled a lot of that data. There's a number of reports out there that put that together. And the map shown here on the screen, I think, has a total of just over 100, just around 100 wells that have data in that category. That's literally all we know about deep non-potable water resources is shown here on this map. And so some of the dark big ones that are red are places where water is very, very salty, over 100,000 parts per million salinity. So that's like beyond seawater, pretty gross, probably more in the realm of where they're extracting oil and gas. And then there's other places there where even at depth greater than 2,500 feet deep, we're still finding fresh water. So there's a couple blue points on the map up there that you can see that there is fresh water at depth. So this is a really important concept that I think we need to do a lot more research and have a greater understanding of exactly what our brackish water resources look like. Because at this point, I don't think we have sufficient geology and water quality and aquifer properties characterized for these brackish water to really step forward on perhaps building a desal facility in a particular area. So what we are working toward to answer these questions and get to the bottom of all of these aquifers once and for all is this is our recipe here. Just 5 simple steps. First, it starts with compiling all that existing data. So all that work that Rachel has just mentioned about synthesizing and grabbing all the data and making sure that we can quickly get to it helps us get to this topic number 1. Several regions like Albuquerque, Santa Fe, Las Cruces have a lot of existing data, which makes it a huge step forward to begin with. Then we can, from that data, build some first draft maps and models. And from those, look and see, okay, where do we not quite have enough information to answer those important questions that we started with? Then this is where the money comes in, where we need substantial data gaps to be filled. And the problem is that to fill the data gaps, this is why it hasn't been done, requires an investment. We have to drill wells to explore what's going on in the subsurface. We might need to do some geophysical surveys. Some of those come from a helicopter. They fly over multiple times and start to see what's going on in the rocks in the subsurface and how resistive they are using these geophysical survey equipment. I'm not going to get too far into it, but surveying from the sky, from the land, even using some remotely sensed data, we can start to fill the data gaps that exist that we don't have enough information presently. This is where the investment happened. And then we go back, plug all that new data back into the model, put it back together and see, okay, do we have everything now? And this is really what's going to help us, I think, start to understand what the interconnection potentially is between our shallower, fresher resources and those potential deep brackish water resources. We need to drill through and see exactly what those interactions look like. And this doesn't mean we're producing water. These are drilling for science, looking and seeing what the subsurface actually looks like. And then dedicating those wells, as I mentioned earlier, to have a device in there that's tracking groundwater level changes, perhaps tracking temperature changes and other water quality characteristics. And we can come back to those periodically and check and see what water chemistry and how it's changing over time. So some of the things that we're doing towards this aquifer characterization effort is building a small steering committee. People, just a few of us. I think I saw Phil King pop on here. He is already named on my small steering committee. Several people who have worked a lot around groundwater who can help guide which areas we work in first and what are some of the key things that we need to know about in those areas. Collaborating, this is going to be such a huge collaborative effort. While we're working to address this challenge, we are going to be reaching out to our other university partners and researchers, state agencies, absolutely, including many of those that were on the Water Data Act. Federal agencies such as the USGS, Bureau of Reclamation, are going to be key partners in making a lot of this happen. And working with a lot of local agencies and perhaps water planning groups as well. I expect that we're going to have some people hired here that are working on this, but we're also going to have to reach out and work with various consulting groups and people who are experts in these geophysical surveys and help us build the models so that we can address these things. So this is massively collaborative and definitely going to be interactive with a lot of different groups and consultants out there. And then, as I said, all of the effort doesn't just turn off when we're done characterizing all these aquifers. We still need to keep track of what's going on, especially if we're going to be considering using some of these deep non-potable resources. So I like to envision that in the future, maybe 15 years out, we'll have this really amazing dashboard with 100 dedicated wells, along with all those other wells, where we're really carefully tracking what's going on in our groundwater levels. We can quickly pull that up in a water planning meeting and say, look, this is what the trend is in our area. We'll have visuals that help people get the three-dimensional picture of what that aquifer looks like, where there's different layers, where there may be potential brackish water alternatives. And then with that, I think we'll also have that better information that we need for knowing exactly what the water quantity is and what the water quality is, and how productive various zones are in the aquifers. So our work right now, literally just today, we had our presentation to one of the upper levels of higher education, since we're under that section of state government. We are continually trying to increase our budget to address this, and we're working on this in a variety of ways, including state funding. This slide covers where our goals are in the state realm. We're seeking an additional 1.25 million for recurring budget here at the Bureau of Geology to support staff, licenses, data management efforts. And then in the non-recurring category, the big ticket, all of that new data collection that really needs to happen so that we know exactly what's going on in the subsurface, is on the order of 175 million. And that is what we expect it to take over the next 12 to 15 years. There's been several requests that we do it all in a year, which is literally impossible. We'll do it as fast as we can. Love to collaborate with a lot of people, but literally not enough people in New Mexico, or maybe the earth, to do all that fast. So our budget request has gone in, and we are trying to get somewhere on the order of 28 million for the next 3 years. And hopefully we can incrementally build that. Also pairing that with philanthropic contributions and perhaps some other federal funding sources that we're also exploring right now. So I think we have reached the conclusion of our slides, and you guys are amazing to hang in there. And we'd be happy to entertain some questions. And I do encourage you to reach out to us by email if you have questions or want to discuss things further, or to Layla if you have a neighbor who you want their groundwater level monitored and you want to make a suggestion. So thank you for sticking with us, and we'll let you, Brittany, help us with questions.
Fabulous presentation. Wow, so much data and really interesting graphics. I kind of had no idea how far you all have already come, and I know there's still a lot to be done, but I'm really impressed with what you guys have already. Someone, just to quick spin off your one of your last statements, Stacy, someone asked, could you do it in 5 years?
Well, this is literally the discussion. So my husband, Mike Timmons, is currently the director and state geologist here. And so our evenings in the last 6 months have been literally discussing how fast can we go? How fast can we get this thing done? And I think I would say maybe I would rather have a substantial upfront fund that we can start working this from and figure out. I'm a little nervous that the first year is going to be tricky to figure out and navigate through state procurement challenges. We have funding limits that we can move out the door. And so that's one thing that the first year, I think we're going to be working through a lot of those challenges. But yeah, maybe, I'll say maybe for 5 years.
That's a good answer. There was a question early on about the recharge map that you showed with the different colors. And if you could explain a little bit more about what you know about recharge from streams and canals and irrigation, acequias, if there's recharge coming up off of those. Some of the big rivers were highlighted on that map, but I think they're asking about some of the smaller streams.
Sure. Yeah, I would say there's kind of two different categories of recharge as we see it. There's what we call diffuse recharge, which is the kind of recharge that happens as snow melt infiltrates in the high mountains areas. And then there's focused recharge, which is recharge that's happening in the streams and arroyos as they're kind of at times during the monsoons or during snow melt runoff periods. There is definitely recharge occurring along arroyos at times, and along the rivers and the sepia. So it isn't really well highlighted on that map. I mean, you see the strip of the river, and it probably is, it is very narrow right around the river and the irrigation canals where that recharge is happening. So yes, there is absolutely recharge happening along the rivers, and we see that in a lot of those carbon-14 dates where some of the most young water that we get from groundwater is right there along the river. Yeah, so
I would just say it's not as much as we always expect, because sometimes our precipitation comes in such flashy, short events that there really isn't a lot of time for it to soak into the surface before it just moves through the system. So the perennial rivers have a much different system than the flashy arroyos.
Yeah, that's a really good clarification. On that same map, we had a question about the beige areas. Is that no recharge, or is that we don't have enough data to know if there's there?
So that was modeled information, and the number is less than about 2% of the annual precip that falls in that beige area. Less than 2% of the annual precip makes it to recharge the aquifer. So that isn't none, but most of that water that falls in the beige areas is either evaporated or transpired off the surface, or intercepted by vegetation and then evaporated from that. So not a whole lot. Yeah.
Are there any particular areas that need monitoring wells that would like people to sign up and reach out to, like certain neighborhoods in New Mexico that you don't have anything that you're really looking for participants?
You could look at our maps online if you want, and you could see where we have coverage and don't have coverage. So our online map that has that information spatially. But sometimes, you know, like our technicians were just out in the field, and they, it's an area where we seemingly have a decent coverage of wells, but the person wanted us to monitor a much deeper well, so it's probably hitting a different aquifer than the other wells we're monitoring. So, generally our rule of thumb is if you're really interested in your water level, we'll come out and help you assess it at least one time, and help point you to, if it's too close to existing monitoring, we'll help you say, okay, this really does seem equivalent to this nearby well. Otherwise, I mean, of course, if we had our way, I'd take every single well that came, but this is all philanthropic funding, so I have to stretch it as far as I can. So if there is monitoring nearby that seems duplicative, I will try to help owners find that.
Yeah, and you can see on the map here, there are tiny black points. Those are the points where USGS and Office of State Engineer have an arrangement to measure groundwater levels. And then the red points are places where we're measuring with this philanthropic funding from Healy Foundation. And so pretty much everywhere else is fair game. If you have a well out there, we'd love to hear from you. If you have a well nearby there, we'd love to hear from you. The fact of the matter is some of those blank spots are Department of Defense. Some of them are tribal, some of them are literally no wells in those areas. So, but if you know some folks out, you know, in I think the San Juan Basin, there's those spots that Layla was talking about. I don't know if you can see my cursor, sort of in the Santa Rosa area-ish. Yeah, there's all sorts of spots that we still need monitoring. So yes, help promote this. And the QR code actually on this screen, if any of you have tried using them, this one is pointing to a report that we developed to evaluate where we would drill wells for monitoring, but many of those areas highlighted in that report are also relevant to where we'd be looking for groundwater monitoring as well.
Thank you so much. That's very helpful. We had a question on the boundaries of the hydrologic basins map that you had presented, and someone was questioning what is the central closed basin on that map.
That's funny. Yeah, we just changed the name of it. It's just central.
Yeah, that name, most of those basins are hydrologically closed. That's why we labeled it that way, but we realized
confusing.
It's confusing, so we're just gonna call it the Central Basin, but that's Estancia Basin, Tularosa, Granada del Muerto area. Salt Basin.
Thank
So closed meaning it doesn't have a flowing river going through it. It's the kind of reasoning for why it was called a closed basin. So it's now called the Central Basin to hopefully eliminate some of that confusion. Many of our basins are technically closed basins, and that doesn't have a flowing river sort of definition. So
yeah, that's very helpful. On that same map, we had a question about how does this map work with the Water Planning Security Act and how the ISC is going to form their delineation of regions, and if you could speak to that for a minute.
Yeah, we're in communication with them, and they are very curious to follow along with what we're doing. I think one big difference, what we're doing is we're really trying to focus this on groundwater. And so this started with I don't know if you guys are familiar with hydrologic unit codes, but that is kind of how the hydrology on the surface is divided up, and there's different scale. Like you can take it down to like a very small stream or up to this whole entire river basin. This is the HUC 6 modified. So it started as a much bigger, it started with a variety of we have modified it. So I'm not sure that it's going to be a perfect alignment with what the Water Security Planning Act is aiming to do, because this is groundwater. And everybody's regions might look a little bit more surface water oriented, because that's, I think, how most people tend to operate. So we're discussing it with them, and I think a map similar to this was in their options for discussion, and I think it's a popular one that hydrologic boundaries make sense for Water Security Planning Act implementation. So I'm a little bit, some of the lines that we've drawn are groundwater oriented. And so I think we'll have to kind of come to some slightly thicker lines to get through those regions. And yeah.
Picking boundaries is absolutely
Always
the hardest part.
The hardest thing. It's just
the hardest for us.
Boundaries. Boundaries are hard for humans, aren't they? Just like as a general thing.
Just generally, yes. We had someone had a question about your budget, and if you could clarify whether the legislative request for the 20 million over the next years is additional to the agency's regular annual budget, or if it's similar to.
Yeah. So that's why the 28 million is a non-recurring budget request. So that is means it doesn't stick year after year. It would just be that one time where we requested $28 million to start tackling some of that data gap. Our recurring budget request, which would be added to our operating budget, what we're aiming for is for aquifer characterization is 1.25 million. And that there's other things that we're trying to also fix our budget with, but that's the aquifer characterization budget request.
Someone had a question on data quality control. How does the data cataloging program deal with contradictions between multiple data sources?
Yeah, I think that's a good question, and it's one that comes up a lot. We're at Water Data Initiative, we are working towards a federated data model, which means that we don't control other agencies' data, we just work to make it more accessible. Every agency or organization that's collecting water data has different quality control requirements. If you're the DoD, you have UFP QAP, and then there's like everything all down, all different types of quality control requirements. So what we try and do is just be transparent and have a lot of appropriate metadata with those data sets so that the user can see what the quality control requirements were for that particular data set and evaluate that themselves, or go to that agency to make it very easy to see where they need to go to that agency's website to see what the quality control requirements are. So right now, we don't want to mess with other people's data or ask them to, and we don't have any regulatory control either, so we can't force agencies to meet some sort of quality control standard. We just want to have transparency about what their standards were when they collected the data.
And I would just add on that, I think that, you know, in that endpoint, after the beaver dam and after the beavers integrate the data, which is our water data team, those applications that are developed, this is where that magic can happen, where we can start to put all the different points that are stacked in that same spot and be like, oh, these are the same, and create an understanding and a kind of a connector to those data sets through applications, where we're not actually modifying the original data, but we're able to see that all, you know, 6 points here in the same location relate to that same point of diversion. And so that's, I think at the end point is where we're going to be able to really do some really tremendous QCing and connecting of data sources.
Thank you. That's very helpful. And
Harold is a fan of the beavers too.
yes, I'm a huge fan of the beavers, and I was just gonna say, you guys are busy as beavers are, with all of this data and I just can't fathom the amount of the volume of data that you're compiling and trying to get integrated into the system where you can crank it out and present it in a way that, you know, the general public can understand. We had a question early on before you told us that you were going to make it more intuitive and understandable and have those tools available at a later date. But, you know, someone said, can you guys make it a dummies guide to groundwater aquifers in New Mexico? Which I thought was a great comment. So we definitely want to have you back for that presentation when your tools are ready for demonstration.
Great. Yeah.
So those were most of our questions for tonight that got written into the chat. Did anyone else have a burning question that you didn't put in your chat? If you'd raise your hand, or, oh, sorry, they're already posting them, mad dash in the chat. Do you expect any groups might oppose aquifer mapping?
Oppose aquifer mapping? Yeah, actually. There's some people who would, this is my human cynicism, but I think there's some people who would rather just keep their head in the sand, quite literally. To not know allows room for speculation, and by continuing to operate the way we do, it in some ways is easier to just continue to fly blind. So I think that there will be potential, but I do feel like, you know, in the context of perhaps any sort of economic development or growth for the New Mexico, any smart business is going to want to know with a little more certainty what available resources are, and what quality that water resource might be for their use. So I think it's a wiser choice to look up and be okay with what we might find, good or bad, and move forward with knowledge instead of fear. Yeah.
I would add that we also have a lot of work in our state to respect tribal data sovereignty in these issues, because it's not really fair to ask them to make all of their water data public if their water rights are not adjudicated. So I respect that need for privacy of data.
Thank you. That was a great answer and a great addendum. Is there any information on the effect of flood irrigation versus drip irrigation?
I would point to Water Resources Research Institute and a lot of the work that they've done over the years. There's a lot of local studies, and I don't know if Phil King is still on. I would also ask him that question. There is a lot of work on that. It isn't something that we have focused on as much, because that's really very much in that shallow kind of vadose zone, not necessarily deeper aquifer interaction. But yeah, there are efficiencies to be had by switching to kind of drip irrigation, but challenges there with salt buildup and perhaps less connection back to the aquifer if there is one to begin with. So it's something we're kind of peripherally tracking, but not actively working on here.
What is the potential for developing in the near term a model of the inner valley aquifer in the Albuquerque area? Irrigation feeds shallow ground, recharges shallow well.
Sorry, did you catch that question?
The potential for what's the potential for developing in the near term the Albuquerque Valley aquifer, and how the irrigation feeds shallow groundwater in that particular?
For new development in the Albuquerque Inner Valley, I don't think there's great potential there because of water rights challenges. There's just not a whole lot of new water to be developed. And then for sure there is interconnection with the irrigated valley and infrastructure to help kind of support groundwater right in that area and recharge that. I'm not sure I'm answering the question enough though.
I'm not sure if I asked the question quite how the person who posted the question was meaning for it to be asked. So if there's a clarification, please go ahead and ask that in the
I would
chat
just
or
add
unmute yourself.
There's also USGS work and work of ours in the Rio Rancho area that we're still working to publish. That has some water resources information in that too that hasn't been published. If that's what you're asking about, new research in that area. There is some gravity studies with the basin.
Yeah, they're tracking microgravity, like tiny amounts of groundwater change and how that affects the gravity of that area, both in Albuquerque and Rio Rancho that's being done. And I think there is a good number of monitoring wells in those areas so we can see what changes are happening along the river as well.
So check back for those reports later and they may be published at a later
Otherwise,
date.
it's the 2D aquifer, the storage maps I was talking about earlier from the Albuquerque region that we do every year. So there's also that.
Thank you.
So what the question was about, this is Norm, was Mike Hammond said that we're going to need to have a new system that treats the groundwater and the surface water of the inner valley as one water because it's used as such. And it seems to me that we need a model of the shallow aquifer and the way it's used. Rip Anderson asked the question in the chat, is there any info on the effect of flood irrigation on aquifer recharge? And I just tried to ask the larger question that I think is a system question.
Mm-hmm.
How do we transition to understanding the shallow aquifer as interconnected with the irrigation system and drains, integral to that, and also integral to all of the shallow wells?
Yeah, that's going to be increasingly important. And I think those sort of like deep dive studies would be spin-offs of the work that we're doing on the broader regional perspective and putting together the conceptual and the schematic pieces of all of that. So it kind of similar to the Water Data Act, I envision that a lot of this aquifer characterization work that we're aiming to do will be a launching point for more deep dive research and kind of site specific questions such as that and model building that's going to have to come along with that. So.
And our model building, our 3D model building right now has been really focused on the most data rich areas of our state. So that's why we were in the Southeast where there's so much oil and gas data to make our model. So we were really trying to understand the modeling process ourselves and what we can and can't do and what our limitations are before we started moving into the geologically complex rift system. And even now, we're going to have to start investing in other software and other techniques really as we move into these data poor areas where it's a new frontier for us in 3D modeling.
What is the best way the public can advocate for funding the outline 2025 session?
Yeah, so I hope that the budget request that we have in right now, it just went to Higher Education Division. Assuming higher education approves it, it goes on to the LFC and DFA to approve and create their budget. So that's the executive budget and the legislative budget get created. And we see those usually come out, I think, in like December. And so once those budgets are out there, that's where I think advocacy can really help to either like align them if they're different, or ask one group or the other to increase or change or kind of accommodate where things are. So that I think we're right in the middle of the process right now, and the direct contacts are not necessarily legislators right now, but more in the staffer domain. So I'm not sure exactly who to point people to at this point, but look for budgets coming out, I think, in December or so. Yeah.
I think we have time for one last question. Ralph, you had your hand raised. Would you like to unmute yourself and ask your question?
His arm must be so tired.
So tired.
Hi, Ralph.
Okay, I better lower it so that I can get untired. Yeah, mine are actually like me 3 questions. One, to Stacy, your last point about when you think that the LFC might be coming out with their budget in December is, a lot of us, we're not always going to be aware of that data coming out and where to find it. Is there any way that maybe you could push that information to us? That would be very much appreciated, because this has been, the Water Advocates has been really promoting the fact that the Aquifer Mapping program needs more substantial and sustainable funding.
Yeah.
Then there was a question. Thank you for nodding your head on that. Then there was a question. I think Jeannie Logston, if I'm saying her name correctly, she asked. Maybe this is a dumb question, but I would ask this question too, and that is, can groundwater be owned by private entities? And then I'm going to throw in my last question. Where is that water scene that was in your question slide? Where is that located? Or is that a private secret spot?
Your last thing, slide, where is that?
Oh,
looks like
the
it
email
was-
addresses?
Yeah.
Oh, I'll put that back up real quick.
Brittany, I know I snuck in 2 more questions.
That was a few questions, yes.
Can public entities own water? Was that the question?
That,
Yeah,
Private
can any
entity.
private entity own groundwater?
that comes into the lawyer realm.
Yeah,
We're hydrogeologists, but you have
I would just
the
say that
Office
the
of State Engineer.
Office of the State Engineer regulates that, and as the kind of the San Augustine Plains applications have shown, that if you don't have an end user, you don't just get to speculatively buy water in this.
Yeah, that was a great decision. Thanks for using that one.
They've immediately appealed that latest decision, but that is how it's handled. And so.
So where is this gorgeous photo from, Stacy?
That is along the Chama. That was after, we call it, gosh, this is terrible. We call it cow poop camp because there's so much cow. It's along the Chama, right along the right side, just a couple of miles down before the rock garden, little riffle.
It must
All
be
right, thank you.
above or below what we call dead cow in the middle of the river rapid.
Yeah, there you go. Everybody has their names for those spots.
All right, well, I think we're gonna wrap up. We have a couple of announcements to make. I'm gonna take over sharing if you don't mind, Stacy. So
Thank you.
thank you, Ralph. We always want you to take something away from our workshops, and so we have 3 requests of you tonight. The first is votes. Please vote. No matter who you vote for, please go out and vote. Early voting is open if you don't want to go and wait in line. So please make sure you get that done before the election day comes and passes. We would also love for you to register for our November workshop, and I will post the link to that in the chat momentarily. We also have a autumn newsletter that will be coming out in later next week. We've got some great articles there, so please take a moment of your time and give those a read to get some really in-depth information about some of the things that are happening, especially around produced water and brackish water, as well as some other interesting articles that we'll have in that newsletter. We will have our final workshop of the year in November, on November 21st. It'll be on Mexico's water resource management priorities for the 2025 legislature. Norm Gom will actually be presenting with LaDonna Clayton. LaDonna, I apologize, I did not get your name onto this slide before we presented tonight, but LaDonna and Norm will be presenting. And then we will be taking a break for December, and then we'll start back up again in January during the legislative session. But that November workshop you can come to kind of get more information about how you can personally help with making sure that our agencies get the funding that they deserve to do this really important that they have done. And so, again, I will post this in the chat for you. Oops. If I can find my Zoom page, it always seems to disappear when I pull up my shared screen. So please join us in November. There's the link for you there. Would like to say a great big thank you to our sponsors. As always, Amigos Bravos, the League of New Mexico Women Voters of New Mexico, 350 New Mexico, Interfaith Power Night, and New Mexico Lounge. Thank you so much for your support of these workshops and getting the we couldn't do. And we couldn't do it without all of you. Thank you for spending your evening with us on this nice chilly fall evening. If you enjoy these events, we would love if you could contribute in any way. We are looking for some volunteers for our organization right now. Specifically, we are in need of a secretary for our executive committee. So if you are really good at taking notes and writing minutes and you need a new organization to volunteer with, we are open and willing and wanting you to join us. So please do that. You can contact me or Norm. I'll put our email addresses in the chat if you're interested in that volunteer position. We're also always looking for social media content creation, and I would love help with producing the newsletter. So if those are in interest to you in your volunteer realm, please contact me as well. Thank you so much for your time with us tonight. Really appreciate it. And as always, we will get the recording of this meeting posted to our website along with the PowerPoint so that you can go back and look at all of those fabulous slides with all of the intricate data on. Thank you again, ladies, so much for your wonderful presentation tonight. And we look forward to having you back soon, hopefully.
Thank you.
Yay!
Thank you.
Yay!
All right, good night, everybody. I'm going to end the meeting.